Welcome to our webinar, A New Standard in Adhesion and Cohesion Testing. Thank you for joining us. My name is Dietmar Lerche. I'm the General Manager of LUM, a company situated in Berlin, Germany. As the technique was developed together with the Federal Institute of Materials Research and Testing, we will also have the seminar together. Let's first quickly introduce Dr. Beck. He studied physics and works in different companies, and since about 20 years now in the Federal Institute of Material Research and Testing. He is now the head of the Division of Surface Modifications and Measurement Techniques, a very long name. What we are going to talk today. Here you have the contents. We are starting with a short introduction, then we will focus on measuring principle and centrifuge technology. Especially, of course, we will try to explain you the preparation of the samples and the measurement itself. Finally, we will show you some applications. On the one side, bonding strength determinations, and on the other side, adhesive strength determinations. And finally, we will have a summary. So here I will stop and I will hand over now the micro to my colleague Uwe Beck.
The quantitative determination of bonding and adhesive strengths is of big importance for plenty of applications such as automotive and aerospace, construction materials, composite materials, and many, many others. The only quantitative test with a unit force per area, that is Newton per square millimeter, has been the pull test within a tensile testing with machines so far. It meets the following international standards: bonding strengths DIN EN 15870 and adhesive strengths ISO 4624. One out of several semi-quantitative tests is a peel test. This test is used to test either bonding strengths of adhesives, adhesive tapes, or adhesive strengths of coatings with the unit force per length, that is Newton per millimeter. It meets the ISO standards 8510 and 9211. Among plenty of qualitative tests, the cross-cut test or cross-hatch test may be used for evaluation of adhesive strengths of coatings and varnishes. It meets the ISO standard 2409. To sum up this short introduction, we would like to know which testing method do you use. Please contribute to our quick poll right now. We will wait about 1 minute before continuing our webinar. Please vote now. So we are following the voting procedure right now. They are all ready incoming votes.
Okay, so let's stop here in this moment, and we are getting more and more polls, but it's interesting now that 44% of all the participants use the tensile test machine, 20% the peel test, 4% cross-cut test, 20% not any test so far, and 12% are using others. So I think it's a good community, so from different sides, and we'll now go and start with a new technology which was developed in Berlin together with the BAM. This is the Adhesion Analyzer LumiFrag, which is designed for your task to determine cohesion, adhesion, and composite forces precisely and more efficiently. This analytical centrifuge, as you can see here, employs always radial directed centrifugal force as loading force and can test up to 8 different samples simultaneously. And of course, it applies to the most often used standards for tensile strength tests and for measuring adhesive strengths of coatings. The compact instrument fulfills different standards, as we told, and on the next slide now you see we will go to explain a little bit more the measuring principle and the preparation of the samples. Let's start with the preparation of the samples. So what we normally have is we have the sample assembly, and the sample assembly consists of the substrate, the blue part, and the stem, and there may be, and of course the adhesive, there may be some coating in between, and this system is used to determine the fracture of the bonding. On the right side you can see how the system is looking like under normal conditions, the pictures, and now we will come first to show you 2 slides regarding the physics, what is behind. So here you have again the assembly, and if it is put together you will put it into the rotor. You can put in 8 different samples and you start the centrifuge. And then, of course, if it's starting to turn, you have an angular velocity. And we know from the physics that based on the angular velocity of the distance of the center of mass from the center of rotation, which is here like r, and the mass of the system, you can calculate the centrifugal force. And what is interesting and important, that the centrifugal force is always directly in the direction of the radius. So this is something that we are preventing any shear force in addition to the normal force. If we know the area where the 2 parts are put together or glued together, then we can of course determine the strengths, bonding strengths or adhesion strengths, and we are getting the Newton per square millimeter or megapascal data for our system. If the RPM is increasing, then finally the critical load is reached and the bond breaks, and then you can also investigate the pattern of the failure. So you can get adhesive failure. In this case, the coating is on the substrate, no changes. In this case here, we have the cohesive failure. This means the adhesive did not withstand, and you can have something in between. You can have multi-layer delamination, means all the layers are taken away, and you see on the pattern the substrate, but you can also have interlayer delamination, then maybe also one or the other layer is taken away, and you see a picture which looks like this. The next part, I'm going a little more deeply into the sample preparation and the measurement. So in principle we have 3 main parts. This is the test stem, we have the substrate, and we have the adhesive. And we are also providing some tools which help you to prepare the system. This is the sleeve, this is centering, the test stem, and the substrate. And this is a tool that you can prepare 8 different samples more or less simultaneously. So here's the animation. So we have the test stem, you're putting on a special amount of adhesive. You take the substrate, you put on the substrate the sleeve, and then you just slide in the test stem with the glue, and everything is finished and you have prepared your sample. If you have several samples, then you can use the centering tool. You have the 8 substrands which you are putting in, then you are putting on the sleeves, and finally you will insert the different test stems, and so you are very quickly have produced the 8 samples. The next thing is how to measure them. So you are starting normally, you open the centrifuge. Here you can see how the system looks inside. This is in principle the measuring module. These are the assemblies. And what you have to do, you have to slide in the assemblies into the module and then to insert the module back into the rotor. This you are doing with all the 8 samples. And normally it takes you about 1-2 minutes to insert all the 8 samples. You close the rotor, you close the centrifuge, and this is everything how to prepare the things. Now we are going to tell the centrifuge, the analyzer, how he should run the experiment. This is made by a special software CEPView. So what you are doing, you can insert freely different names for your samples. You can, this tells you of course in which channels is introduced. You have the test stems. Here in this case we use for all samples the same test stem, but you can also use different ones. And here you can add some comments, how the sample was prepared or something else what is important to analyze the data. And it's not necessary always to put in the test stems, but there's also a library which you will now see, so you can easily just use the different test stems, and this gives you also the opportunity that the system itself knows the mass of the test stem and the distance from the radius. The next is what you are doing, you have to describe the protocol, the SOP, how to measure, how to increase the load. You have different possibilities. You may increase the load or you may increase the RPM. You can establish how quick the load has to be increased, how far the load has to be increased, means maximum load, measuring time, how long you like to measure, which is given here, and which temperature. And there is a simulation tool which gives you immediately and shows you how the load will be increasing over the time of the coming experiment. The next thing what you have to do is to start the experiment, and now the system is starting to run. You can see here how the load is increasing, and the system is online calculating the current load for the different samples. In the moment you see the load is increasing for all the 8 samples, you see how the increase is going here. Up to now nothing is happening, but now the first failure was detecting and the column stands, and you have here immediately indicated what is load, the critical load, and what you can see here now clearly, these are less stable, the strengths are much lower than for these things. You have the data also already here in the table, and this data can be easily exported into Excel, and then you can go and do some additional analysis. If you have everywhere the same type of samples, you get also immediately the mean and the standard deviation of the experiment. If you finish, you open the system, you put out the samples and the substrates, and as you can see, you can very easily now also watch the pattern of the failure and classify the failures regarding whether you have adhesive, multilaminar or cohesive failures. So we very quickly showed you the physics. We showed you how to prepare the samples, and we showed you how to do the measurement. And just interesting now, what do you think? Please tell us what you think of it. We will have now our next poll. Again, it's about 1 minute, and just feel free to answer the questions.
So there are incoming votes, and we will shut down the voting procedure in a few seconds.
It's interesting. 52% found it quite interesting, 36 need more information, and 12% are not yet convinced, so we have a little bit to work about. Uwe, now maybe you go and show the applications.
Yes, I will do so, thanks. So, as already mentioned, let us discuss now some applications. We will begin with examples for the determination of bonding strengths. The first example is a comparative study on different materials bonded to copper by polyurethane adhesives. It is to be seen that one can easily evaluate bonding strengths in terms of a fast screening for various material combinations. In addition, and probably more important, the standard deviation is rather low, ranging from 5 to 10%. The second example addresses polymer bonded to copper by cyanoacrylate adhesives. Also here, a fast ranking of the adhesive and material combinations is possible. The standard deviation is somewhat higher, in between 10 to 20%. However, much smaller as in a tensile testing machine, as no shear forces are present. The third example describes the influence of composition of 2K epoxy adhesives and curing temperature. Both mixing ratio and curing temperature may affect the quality of an adhesive bonded joint. Best practice parameters may increase bonding strengths, as to be seen here, by about 50%. So this is a rather important feature. For polymers of low surface energy, such as polypropylene, good bonds are difficult to achieve. Without any chemical cleaning and any plasma treatment, bonding strengths may be as low as 0.3 MPa. Such low values cannot be measured in a tensile testing machine because the bonding fails during clamping procedure because of the shear forces. For optimized cleaning and by additional plasma pre-treatment, bonding strengths can be increased by a factor of 10. Now also measurable in a tensile testing machine. Again, shear forces yield to remarkably lower bonding strengths values in that case. Let us move now to applications dealing with adhesive strengths of coatings and films. The first example deals with optical coatings on glass. In this case, almost all failure patterns can be observed, such as delamination failure, adhesive and cohesive failure, interlayer delamination, partial delamination, or even substrate failure. To identify the failure pattern, a microscopic inspection is required, both on the test stamp side and on the sample surface side. The second example shows ophthalmic coatings on polymers. Adhesive failure, cohesive substrate failure, and partial delamination failure can be observed. The adhesion of the coating is rather good and beyond about 8 MPa. The standard deviation is usually below 10%, which is, from the technical point of view, very promising. The third and last example demonstrates metallic aluminum films on plasma-modified polypropylene foils. To increase adhesion of aluminum on polypropylene, a plasma modification of the polypropylene foil was applied, resulting in an adhesive strength of about 2 to 2.5 MPa. Usually the peel test is used for determination of adhesive strength. However, this test fails here as adhesive strength of aluminum on modified polypropylene is already beyond the peel strength of the adhesive tape to remove the coating. So one can not observe any delamination by means of the tape peel test. However, centrifuge technology can achieve this goal. With that, I'm at the end of the application section, and I would like to turn over to Professor Lerche again.
Okay, so thank you, Uwe, for the interesting applications, and I think we saw already that really very different systems can be investigated and analyzed. I'm trying now to summarize a little bit about what we talked about. And we are starting with we started with a comparison of systems, tensile testing machines, and we will now add the centrifuge technology. So here I just come once more to the direct quantitative comparison. We had already a few comparisons in the talk, in the application part before, and here we have measured different times copper steel joints with the pull-off test and with the centrifuge technology. And what you can see here, that in principle the data, the mean values are about the same, and we have standard deviations, what is quite usual for a pull-off test of about 20-30%, which with all our experience are mostly a little bit lower if we run the system on the centrifuge. This may be due to the reason that we don't have any shear force implied to the joint. Now let's come to the next table to go to a little bit more points regarding the comparison. So the first and maybe striking point is that tensile testing machines can measure one sample in one experiment. The adhesion analyzer can measure 8 samples in one run. This means also that normally it takes you 5 to 15, or in complicated situations maybe 30 minutes for one measurement. In our case, we have one measurement altogether in 15 minutes for the 8 different samples. So this gives you about a saving in time of 85% already. Regarding sample dimensions and geometry of the samples, there's an advantage here that you can also use very large ones, what is not possible in the analyzer. But here we can run samples up to about 30 to 30 millimeters. But what is important, that the geometrical constraints regarding the sample are very small, and you can use circular ones, you can rectangular ones, you can have glass samples which are broken out from a larger part. So from this point of view, you are very flexible. Next up, let's come to a little bit more to technical questions. With the tensile testing machine, there's a two-side clamping to mount the samples. With the Lumifrac, you have just one side support system, and you saw the sleeve is supporting the substrate, so there is no clamping necessary. Regarding testing climate, tensile testing machines normally are bring to some climate chambers, so you have some housing which is required. Here, regarding temperature and humidity, this is built in. You can change the temperature from minus 11 degrees up to 40 degrees and also change the humidity. what, of course, test stems have to be bonded to the corresponding material or to the coatings. This is required in both techniques. And then, just to repeat it once more, we have single sample, or you can measure and test a batch of samples. So what else? We already talked about that shear forces in the adhesion analyzer normally can't occur because the centrifugal force is directed in the direction of the radius. This is different with the tensile testing machine. Here it's very difficult to avoid any shear. Regarding the force range, there are different instruments of the market regarding the tensile testing machines. Normally the force range is about 3 orders of magnitude. With the adhesion analyzers, you can measure from about 100 millinewton to 6.5 kilonewton with one system. The reason is that we can change RPM, we can change the mass of the rotor, and we can change the area of the bonding. Then, of course, both systems apply to the DIN EN 158070 for tensile strength measurements and the ISO 4624 for coating adhesive measurements. The adhesion analyzer is working force controlled, and the tensile testing machine may work force or pass controlled. So this was a quick summary what we are doing, and the next is just have a look to the fields of applications. We showed you when we started that coating and bonding is more or less everywhere in the production process, from aerospace to ceramics, let's say. And this is what we can do with the adhesion analyzer. In principle, we can measure all very different material classes, starting from metals to glass, ceramics, polymers, semiconductors, wood, and so on. We can measure bonding strengths in different directions, different tasks. You can test and analyze material combinations. You may analyze adhesives, how to cure the adhesives, or another very important point, how you have to treat the surface that your adhesive gives you a high bonding strength. And the next point is that we can of course also measure adhesive strengths. Here it's very interesting that it's not necessary to have to clamp in or to fit in a special point the substrate, so you are very flexible. And again, of course, you may test different material combinations, you may test films, you may test coatings, nano coatings, the primers which are often used to increase the adhesive strength. You can look what is the effect of surface modifications, and you can come to composite strengths for some carbon fiber enforced composites and so on. So this is what we like to show you, to tell you, and now we are here also to answer maybe your questions for in the next, let's say 15 minutes, what we have. So please give us your questions. Maybe we can start to order it a little bit. If you have a question to a special transparency, to a special foil, then maybe you can start your question with the number of the foils, and we can just show it once more, and then other questions we will try to answer here. If this is not immediately now possible, we will answer any question by email. There's also some more information which you can get from the site lumifrac.com, but also from our homepage, and there is literature portal which is called Dispersion Letters. You can just join it, and there are also some articles and so on describing what we talked about, but also production of LUM means also the LumiCyza, LumiReader, LumiFuge, and LumiCheck.